Hello dear students, you are welcome to Ark Institute. I am Dr. R. K. Saini and today I am discuss JEE Advanced Paper 2025 of Chemistry. Some important question from this paper. For example, first question from chemical kinetics, very important question. Read the question carefully. First, a given reaction, their rate is K into A into R. The reaction is given A plus R gives product. According to given information, the initial concentration of R is 10 times of the concentration of A. Suppose its initial concentration is A node. Then the concentration of R is 10 A node. After 40%, we find relative error rate when reaction is 40% complete. After 40% complete, the concentration of A become 0.6 A node, 0.6 A node, and the concentration of R is 9.6 A node. The rate of this reaction, actual rate of this reaction is K into concentration of A, 0.6 A node, into concentration of R is 9.6 A node. Or we can say it is equals to K into 5.76 into A node square equation 1. Now we consider, if we consider pseudo first order reaction, then rate assumption K into R equals to R dash. When we assume pseudo order, then rate of pseudo order reaction is K dash into R, K dash into A, and the K dash equals to, and the K dash given K into R means K into R, concentration of R, initial concentration of 10 A node, because it become constant, and the concentration of A after 40% completion is 0.6 A node. Therefore, equation second is K equals to 6 A node square. Now we find percent error. Percent error means difference in their rate with respect to actual rate. Difference with respect to actual rate, with actual rate into 100. Therefore, equations second and equation first, the change in rate from equation second, assuming pseudo order, to actual rate divided by equation first into 100. And hence our answer is difference 0.24 divided by actual rate 5.76 into 100. Therefore, our answer is 4.18, and JEE given this answer 4 to 4.25 is correct answer. Question number second. Question second is also important, taken from solution. Very important question. In ideal solution, solution of macromolecule, the osmotic pressure exerted in term of height and density दे रखी solution की equal to 2 centimeter. If concentration of dilute solution is 2 gram per decimeter, find molar mass of this. First, we identify osmotic pressure with respect to height. When solution of macromolecule separated by semi-permeable membrane and put in the solution of water, then increase the height of solution, and when sufficient height or hydrostatic force at which flow of solvent particle into solution across the semi-permeable membrane is stopped, then this height or hydrostatic force of attraction is known as osmotic pressure, and it is equals to HdG. Therefore, we write osmotic pressure taken SI unit. Height 2 centimeter. 2 centimeter into means 2 into 10 to the power minus 2 meter. D, density given 1 gram per centimeter cube, taken also in SI unit. Density 10 to the power minus 6 gram centimeter into 10 to the power minus 6 meter cube. And gravity given meter per second. Therefore, our answer is 200 kg and it is equals to Pascal. Now, we use pi equals to CRT. Therefore, C equals to pi upon RT. And this C equals to pi 200 Pascal. Unit of R and T also taken in SI unit. R equals to 3.8.3 and temperature 300 Kelvin. Therefore, this concentration is in SI unit, means this concentration in mole per meter cube. This concentration given mole per meter cube. Now, mole multiply by their molar mass, then the concentration become gram per meter cube. Molar mass, we know that mole equals to weight in gram upon molar mass. Therefore, mole multiplied by molar mass, then we find weight in gram upon 8.3 into 300 into 10 into meter cube. This gram or volume in meter cube. And this is equals to given concentration. Given concentration is 2 gram per decimeter cube, means 2 gram per decimeter cube. Decimeter equals to 10 to the power minus 3 m. And as we find molar mass, this molar mass equals to 8.3 into 300 into 2 divided by 200 into 10 to the power minus 3. And this molar mass equals to x into 10 to the power 4. This molar mass equals to x into 10 to the power 4. By the solving of this problem, the answer is 200, 0, 2, 2, 3 divided by 10 to the power 4, means this value divided by 10, and hence our answer is 2, 8, 3 ja 2.49. Actual answer is 2.49 according to given value of R. Our answer is 2.49. JEE given 2.4 to 2.55. This is the question from solution. Question third. This question taken from electrochemistry or particularly in fuel cells efficiency. The electrochemical fueled combustion of butane 1 bar and 298 Kelvin. The cell potential is F upon this, where F is Faraday constant. Find value of this. Delta G. First of all, we write equation for the combustion. C4H10 butane take part in combustion. Therefore, all carbon change into CO2 and all hydrogen change into water. And hence, we find, first of all, we find delta G of this reaction at standard condition. Given delta G means enthalpy formation. We know that summation of the enthalpy formation, Gibbs energy formation of all product minus standard condition minus Gibbs energy formation of all reactant. Putting these values, the value of CO2 given minus 394 into 4. The value of H2O is also given minus 237 into 5. These are the product minus reactant. Reactant is butane because the standard enthalpy formation of O2 taken 0. And this value is given minus 18. Therefore, we find value of delta G. Delta G node of reaction equals to NF E node cell. This value, put in this value, and the E node. In this, the value is comes in kilojoule. Therefore, this value change into joule multiplied by this, and where N, find N number of electron. The oxidation state of carbon in butane is minus 10 by 4, in which 4 carbons are there, and the combustion, it change into CO2. The oxidation state of carbon is plus 4. First of all, we make balance the atom and then make balance the charge. In left hand side, the total charge is -10. And in right hand side, the total charge is 16. Therefore, we added 26 electron. Therefore, N is 26. N is 26. F E given. N is 26. F into E node X. In this question, voltage X upon F into 10 की power 3. Put the value of this F cancel, and the value of delta G, negative sign with negative sign. Therefore, we find X. It is nearly equals to 105.5, and the J given answer 105.4 to 105.6. It is important question. First of all, we find delta G of the reaction with help of this, and then we know that delta G free energy change equals to minus NFE, and number of electron take part in balance reaction or 1 mole of butane or combustion of the 1 mole of butane. Question next, fourth question. This question taken from coordination chemistry. It is also important question. In general, coordination chemistry is important topic from JEE as well as NEET, etc. Example. Find sum of the spin magnetic moment of the value. We know that spin magnetic moment depends upon number of unpaired electron, and we find this spin magnetic moment with help of following formula, where N is number of unpaired electron. In question first, the oxidation state of Mn is +3, and the +3 Mn contained 4 electron in d orbital. The octahedral complex in which delta O is less than pairing energy because bromine is a weak field ligand. Therefore, 4 electrons occupy 3 electron in T2G and 1 electron in EG, and hence it contains unpaired electron 4. Therefore, their spin magnetic moment is under root 24, or it is nearly 4.89 Bohr magneton. In case of second, in which oxidation state of Mn is also +3, but it is strong field ligand, or in case of strong field ligand, the value of pairing energy greater than value of delta O. Therefore, 4 electrons. Therefore, these 4 electrons occupy in T2G orbital only, and hence it contains only 2 unpaired electrons, putting the value of 2. Therefore, their spin magnetic moment is √8, or it is nearly equals to 2.83. On the summation, it nearly equals to 7.5 to 7.8. Given answer by JEE. Question number 5. This question taken from biomolecules. Biomolecule is another important topic in case of JEE Advanced as well as main. A linear octasaccharide, molar mass 1025, on complete hydrolysis produce 3 monosaccharide, namely this. The amount of 2-deoxyribose weight by weight is 58.this%. Find number of ribose unit in 1 molecule of octasaccharide. First of all, octasaccharide means 8 units. On their hydrolysis, it gives 8 units. Therefore, it requires 7 molecule, and as total mass of octasaccharide after hydrolysis is 1024 plus 7 into 18. 7, because 7 water molecule is required. After complete hydrolysis, the total mass is 1150. Now we know that it gives 3 units, namely monosaccharide ribose, 2-deoxyribose, and glucose, and total units are 8. Now we find unit of 2-deoxyribose. Its amount is 58.26 by weight in 100. Therefore, in 1150, their amount is 670 gram, and the molar mass of deoxyribose is 134. Therefore, it has 6 units. It means X plus Y plus Z equals to 8, where X is ribose, Y is deoxyribose, and Z is glucose. Total unit 8. We find 6 unit of 2-deoxyribose. Therefore, X plus Z equals to 3. And the weight of ribose, X unit, means X into ribose given weight is 150 and Z is the weight of glucose, its weight is 180 equals to the remaining weight of substrate is 480. We putting value of Z equals to X plus 150 plus 180. At the place of Z we write 3 minus X equals to 480, and hence 150X plus 540 minus 180X equals to 480, and hence we find minus 30X equals to 60. Therefore, X equals to 2, and hence the unit of ribose is 2 in this question. First, we find total number of monosaccharide during the hydrolysis of octasaccharide. Octasaccharide means 8 units. And we added 7 units of water molecule, weight of 7 units of water molecule during the hydrolysis, because it required 7 water molecule. Okay, these are the questions of advanced chemistry taken from paper 2025.